In this video, we'll look at solving special triangles, but first we have to learn what they are. So this is all about special triangles in degrees. So let's look at what the special triangles are. There are two special triangles that we use. The first is, well, they're both right angle triangles. The first is a right angle triangle, and the two angles in that triangle are 45. The triangles, all triangles, have to sum to 180 degrees, so 45 and 45 plus 90 is 180. And the triangle sides are 1 and 1. And don't worry, clearly, look, that does not look like they're both the same length, but don't worry about that. As long as you show the relationship, it's a 45 degree angle with a 1 across from it, and an isosceles 45 degree angle with a 1 across from it. The hypotenuse is square root of 2. That's one triangle. Done. What's the second triangle look like? Also a right angle triangle, but its two angles are 30 degrees and 60 degrees. I usually write the big angle down at the bottom here. It doesn't really matter. Again, I didn't have the proportions looking right here. It's not the proportions we're looking for, it's the relationship of the sides and angles. And by that I mean you only have to put the right side across from the right angle. And what side goes across from 60 degrees? Always root 3. In this second special triangle, the 60 degree angle is one of the angles, and up opposite it is root 3. What side's opposite 30 degrees? A 1. And then what's the hypotenuse? A 2. You could use Pythagorean theorem to show these sides have a squared plus b squared equals c squared. Nonetheless, here are your two triangles. The sides are 1, 1, root 2 in the 45, 45 degree triangle, and the sides are 1, root 3, and 2 in the 60, 30 degree triangle. And again, notice the 1's across from the 30, the root 3 is across from the 60. And so now let's put these triangles into use. The first use you'll do with them is simple things by just calculating values without a calculator. I'm not using my calculator here because it says use exact values. So how do I use these special triangles to calculate an exact value? Here's how. Sine of 60 degrees. Instead of punching it in my calculator, I go to the 60 degrees and I remember my SOHCAHTOA. SOHCAHTOA tells me that sine is opposite over hypotenuse. So start at 60 degrees, go opposite, that's root 3, over hypotenuse, that's 2. And so in one simple move using the special triangles, I solved for sine of 60 degrees by going opposite over hypotenuse, and I got that from SOHCAHTOA. Which will help me with the next one, which is cos of 30 degrees. Again, use SOHCAHTOA. What's cosine? Cosine is adjacent over hypotenuse. So go to the 30 degrees and look for the adjacent side, root 3, over the hypotenuse, 2. And look at that, just like sine 60 was root 3 over 2, cos 30 degrees is root 3 over 2. Does that make sense? Here I'm doing opposite of 60 degrees over hypotenuse, and the second question I did adjacent of 30 degrees over hypotenuse. What about tan 45? That's back to the first triangle. If you remember SOHCAHTOA, tangent would be opposite. Doesn't matter which one you pick, you'll get the same opposite, which is a 1, over adjacent, which is also a 1. Look, let's pick this 45, opposite, adjacent. Let's pick this 45, opposite, adjacent. So you get 1 over 1. And in this particular case, since it's a fraction divided by itself, you should definitely simplify that to just a simple 1. That's some basic questions, but a lot of what you're going to do with this is solve rotations. And you'll be given something like this. Solve for cos theta equals negative root 3 over 2. And usually you'll be told that the angle you're solving for, theta, is somewhere between 0 and 2 pi. Which means there's going to be two answers. There's another video on this too if you want to watch that. It goes over, I think it's called solving for the exact value in degrees. But I'll show you it right here. We're going to begin, there's always 3 steps, and it begins with a sketch. The steps are sketch, raw, solve. Here's my first step, the sketch, with an x-axis, y-axis, all my arrows. I get an initial arm starting here. That's my initial start for my rotation. And then I'm going to rotate to wherever cosine's negative. Where's cosine negative? Well, cast rule. So here in quadrant 2 it's an S, so cosine's negative there. And here in quadrant 3 it's a T, so cosine's negative there. Don't worry about the arrows being different sizes or that it's exactly in the right spot, as long as it's in the right quadrant. Cast rule. Where is cosine negative? Quadrants 2 and 3. Label the rotations. This one's theta 1. This rotation to here is theta 2. And inside the triangles, right in the corner here, between the terminal arms and the x-axis, are the betas, or related acute angle, which is my second step of my 3 steps: sketch, raw, solve. I'm on to step 2, which is solve the related acute angle. Now you're solving an angle as if it's inside the triangles here, which means you use the beta, the b value. I don't care if you call it b or beta, but I do care very much that inside the triangle there are no negatives, so you solve this equation with a beta and with the positive version. Cosine of beta equals root 3 over 2. I got that from this equation, except since I'm in a triangle now, it's positive. How do you solve that? The beta would be the inverse of cos of root 3 over 2. But if this question says use exact values, I'm not using my calculator. I go back to my special triangle. And here's what I do. I look for the root 3 over 2. It's this special triangle. And I think, what angle gives me an adjacent, because it's cosine? What angle gives me an adjacent of root 3 and a hypotenuse of root 2? The answer is 30 degrees, which means the angle inside this triangle, here and here, they're both 30 degrees. So my first mark is sketch, my second mark is related acute angle, and you get 2 more marks for solving each theta. Theta 1 is in quadrant 2, which means this angle of this rotation is go 180 degrees and come back the beta. In quadrant 2, it's always 180, take away the angle that you just solved. And so your first theta, or theta 1, is 150 degrees. Sometimes I put a box around it. You don't have to. I'm going to put a line here, though, to separate this work from the related acute angle work. And now I'm going to solve for theta 2. Theta 2 is in quadrant 3, which means rotate around all the way here. That's 180 degrees, plus beta. In quadrant 3, the formula is always 180 plus the angle you just found, the related acute angle. And so this second possible answer, rotation, is 210 degrees. And we've done it. We solved for both possible angles between 0 and 2 pi that give negative root 3 over 2. How did we do it? We sketched, we did the related acute angle, and we solved each theta. And that's how to use special triangles in degrees. Here are the special triangles. Here's a couple of quick examples of how to use them, and here's how to use them in rotations. Hope you enjoyed the video.